Hello students, the question is from computer organization. Okay, so they have given a data of the magnetic disk, the performance of the magnetic disk, where overhead is 3 milliseconds, then average seek time is 10 milliseconds, then rotation rate is 5400 revolution per minute, then transfer rate is 2.88 megabyte per second, then sectors per track they have given as 32 sectors per track. Okay, then sector size they have given as 1 kilobyte. Okay, so in the first part they have asked what is the average time to read or write 16 kilobyte in 16 consecutive sectors in the same cylinder. Suppose this time is A. Okay, so usually when we are calculating the access time, it will be the sum of average seek time plus the rotational delay. Okay, so but here overhead is also given and the transfer rate is also given, so we have to include all these factors. So it will be the sum of all these things, means overhead, average seek time, then transfer rate, and it will depend upon the how many kilobytes is going to be read. If it is, because it is reading 16 kilobytes, so here it will be referred to 16 kilobyte. Okay, means it is transferring 16 kilobyte. It has to transfer 16 kilobyte, but the transfer rate is what? 2.88 megabyte per second. Okay. Then what we have to do is we have to calculate, I said rotational delay, right? So how you calculate the rotational delay? The rotational delay will be half of rotation rate. Since it is given in minutes, so we will convert it into second. That will be 60 divided by 5400, nothing but 5.55 milliseconds. Okay, so now rotational delay has been done, so you have to calculate what? Average time, average access time, you can say. So it will, I told summation of all these values. So overhead is 3 milliseconds plus 10 milliseconds plus 5.55 milliseconds, and we have to transfer 16 kilobytes and rate is 2.88. okay, so yeah, per second. Okay, to 2 megabyte per second. Okay, and it is kilobyte. Fine. So this, if you solve this value, okay, so this will come as 24.16 milliseconds. Okay, so answer is C. Fine. Now in the second part, what they have told is, suppose the average time to read and write entire track. Here the byte they have changed. Instead of reading and writing 16 kilobyte, now we have 32 consecutive kilobyte, and it is also given that the sectors can be read or written in any order. So when in the second part, when the order is not maintained, means we can read and write any sector in any order. Okay, is not maintained, then there is no rotational delay. Therefore the rotational delay will be 0. So when the rotational delay will be 0, then what will be the average access time? The average access time is 3 plus 10 millisecond plus 0, because 32 bytes has to be read, 32 kilobytes and 2.88 megabyte per second. So this will come as 24.11 milliseconds. Okay, and in the question they have asked, we have to calculate B minus A. Assume the previous one was A, this is B, so B minus A is what? 24.11 minus 24.16 minus 0.5 milliseconds. Okay, so this is the answer. So answer is D. Thank you.